I just want to take a minute to go through the simulator for tomorrow, or for today. All right, so first thing you do is you click on the link. It's going to open up the sound and waves simulator. So we're going to be dealing with two simulators. We can do waves. String will be our first one. Wave interference is another one. Now, if you want to play with any of these, you're welcome to. But these are the two main ones that are focused on the simulation lab for today. But again, feel free to look at any of these, see how they change, see how they impact things. There's a lot of neat information there. But the first one we're going to do is our waves on a string. All right, so we are going to activate the simulation. Then we're going to change some settings on it. We're going to change it to pulse. Change it to, make sure it's at fixed end. Damping should be at none. No other changes. Now, if you want to add the ruler and the timer just at this point, you can. They're not going to hurt you at any point. They're not going to impact what you're doing. So those are your initial settings. You can check it from the picture on the form if you're not sure. You're going to press the green button once, and you're going to send a pulse. So when you sent the pulse, what happened? Did it reach the end and stop? Did it reach the end and reflect back on the string? Or did it just continue down the string? Now, we're going to change the setting in the right-hand corner from fixed end to no end. So now we have a window. It's going to go out. We can even restart this if we want. We're going to send the pulse. We're going to watch what the wave does. So did the wave reach the end and stop? Did it reach the end and reflect back? Or just keep going out through the window? Last thing we do is reset this fixed end simulation to fixed end. Now this might be slow motion because it might be easier to see. So we're going to send a pulse down the wave. That is really slow motion. Give it about a second, and then send another wave down the string. And as those two waves impact, what happens? Do they bounce off and reflect? Do they just pass through each other? Or do they cancel each other out? Okay, now we're going to stop the simulator, change it to oscillate. And then we can go ahead and set the waves on the string just to see what it looks like. Now, if you want to do this, we're pause time. We can start our timer while time is paused. And you can count how long it takes for that wave to travel down the string. So we push the button, just see where that wave makes that first impact with the wrench. So we're about that amount of time. Okay, we'd also take one of the rulers and we're going to measure the wavelength. We can either do it from crest to crest or we can do it from trough to trough. It's not going to make a difference. What is our wavelength? Okay, we're going to restart everything, change our setting now, tension to low. And then we're going to see how long it takes for that to change the, we're going to reset our timer, start it. And then we're going to send our wave and we're going to count how long it takes us to get down to the end. So here we go. It's a much different wave when there's less tension on the string. So we're going to wait till that particle, that green particle that's in the wrench is affected, and that's going to be our stopping point. I didn't say it was super exciting. And the timer is automatically adjusting, so don't panic. That's not an actual time. All right, so we're about 6 seconds where the wave has made it all the way down the string. Then we're going to take our ruler and we're going to measure the wavelength of one of our new wave that we've created. So we see we're right around about here. Okay. On the simulator lab, then, you are going to change to the other simulation, which is wave interference. So go back to click on the next link and bring you here. You can go ahead and open it up. You're welcome to play around with the settings, change on the top view, side view, just to kind of see which one. We're going to do the wave section. Do side view, top view, doesn't matter to me. You want to keep it in this setting here. Now we're going to set the frequency to the minimum. Might need a timer. And again, if we pause time and we start the timer, it's not going to start until we actually start a pulse. So this, as soon as we activate, so we're going to time how long it takes for this wave to get from the drop all the way and hit the other wall. So we're going to go ahead and time that. And this is the low frequency. So as soon as that black edge touches it, all right, so we're about how long for that wave to get across? Okay, so let's reset this. This time, we're going to change the frequency to maximum. Same thing, we need a timer. We can pause our time, start our timer. That way it won't start until we start time. Now we're going to count how long it takes for this wave to get across. So you can see we're still around, because it's the same amplitude, we're still around the same amount of time. Look at the amount of waves in that space, though, and that should be kind of an indicator to you how it's different. Then we're going to switch to observing sound waves. We are going to use both waves and particles. And we're just going to send some pulses down there. Well, we're going to start time. And just choose any of the red dots. And as the waves are passing through, what I want you to notice is what's happening to these red dots. Let's focus on this one here, for example. We see as the compression of waves go through it, pushes it back, and then it puts it right back in spot. So it doesn't really leave this area. It just keeps going back and forth as the energy wave passes through it. Now we're going to set the frequency. We're going to pause it. It's a lot of waves. Set the frequency to minimum. We're going to let it play for a little bit. Get the waves set up a little bit. Make sure those are all the same kind of waves we're dealing with. Okay, pause it. At any point now, we're going to go ahead and take our tape measure. And let's go from this spot right here. So from this wave, we'll drive our tape measure out to this part. So from compression to compression, we're about this is our distance. Okay. Now we're going to change our setting to the laser. Lasers. Okay, we can move this off the side. We don't need it right now. All right. What I want you to do is you go ahead and click on the laser. And what I want you to notice is what happens. Here's the frequency. Let's turn the laser on. Let's turn some power on. Sorry. There we go. As we change the frequency of the laser, what happens to the color that we perceive? And we can put a screen on there if we want to see what we would see. We would graph if we want to see what the wavelengths look like. Okay, so if I change the frequency, what do I notice about the wave? So, and then let's go to a couple colors. So if I go to red, look at the space between the waves of red, very low frequency. If I kick this thing up to purple or violet, you'll notice I have a lot more waves per second, a lot higher frequency. Okay, so since we're in purple, roughly purple, we're going to go ahead. We can pause it at any time. Take our ruler. We're going to turn it a little bit. It's a little hinky here. And it always goes from dot to dot. Why are you going on? Yikes. Let's put this back up here. There we go. So we go from one wave. We'll go to like the middle of the next wave. So we're about 400 nanometers. So based on this chart, what is the wavelength for visible light? What is the shortest wavelength, and what is the longest wavelength that we can actually see? So document that. Now we're going to go back to sound. Let's get some of the other stuff off here. We got a lot of junk on our screen here. Let's get this graph out. Now we're going to use two speakers. Oh, we're going to go to interference. Sorry. So interference, sound. And we're just basically going to let these play. Doesn't matter if you start them at the wrong time or right time. The frequency is going to be the same. We're going to let this develop for a little bit. All right, so we're going to pause it here and show you what we're talking about. We can even see the particles. Yeah, because that's a good example. So what we have here, these white areas I want to draw. Sorry. So let me draw. All right. So anyway, these white areas, these are areas where the material is, these are the crests where the waves are being pushed together. Again, or compression. See how these particles here? These black parts are the refractions. And again, there's less particles here in a sound wave. What I want you to notice are, look at these two lines here. They're circled in orange on your Google form. These are areas where those waves are interacting. They're actually causing a fuzzy area where they're canceling each other out. If they're canceling each other out, what kind of interference is that? Okay, we're going to do one last thing. So we're going to go on to this slits screen. We'll start off with this. We'll switch to a sound wave. We pause time if we want, just so we know we're there. So we're going to send a pulse right before it hits that wall. Predict, what do you think that wave is going to do? The phone was going to go off. Sorry, I'll get that in a minute. Now, so what do you think is going to happen to this wave as it hits the barrier? When I press play, what actually happens as the wave passes through it? See how it bends as it goes through the opening. What type of wave interaction is that? After that, you really don't have anything you required from me. What I would recommend, change this. Go to 2 slits. You can change the separation of the barriers. You can change the size of the barriers. Okay, you can change where it is. You can change it to light and see how light waves interact. Just, there's no requirement to this assignment to this part. Just an opportunity for you to kind of play around, but if you play around and see how the waves change, again, those patterns of interference, see how we have those lines coming out, those where we see destructive interference. How do, if I change those slits locations, how does that change my lines of separation? Now let's say I have much more of them. Again, nothing to do here, just kind of playing around. When you're done, go ahead and view your score. You have no other requirements for today. Hopefully, if you have any other questions, please feel free to ask. Have a wonderful day.